Hi everyone. Today we are going to discuss about the TCP IP. So we all know the 7 layers, but the layer 4 is very important, and we got only two protocols for transport. So I would say that that is TCP and UDP. And when you talk about UDP, it's a connectionless protocol, and that's mostly used in the voice applications because it's not connection oriented like TCP. Yep, here the key focus is to discuss about TCP. So when you say TCP, it stands for Transmission Control Protocol. We all know that, right? TCP stands for Transmission Control Protocol. And why we are discussing this here? So before any communication happens between the source and destination, you should really understand about TCP communication. So for a successful TCP communication, you should have this 4 tuple connections. So in the 4 tuple connection, the first tuple is the source IP address and the destination IP address, then followed by source port and the destination port. So let me do this a little different to understand better. So we all call this TCP packets as a segment, right? It's not an all in one go, you'll send your informations here. So if you take this as a segments, and this is your TCP packet. So what I got here is a source IP. So example here, my source IP would be 198.168.0.2. And my destination IP would be 192.168.0.1. And my source port 5601. And my destination port 5602. So what happens here? So this is my 4 tuple connection. As I told you, you need this 4 parameters to successfully send the packet to the destination. In the same way, in the destination, you got the same values, right? So we can understand this self-explanatory, right? So you can understand the same way it happens from the destination to source. My destination, and this is my source. So why this is crucial and important to understand? So if you look at this, the very first packet is my SYN. So I send a SYN with all the 4 parameters, and once it reaches here, and if the destination port 5602 is opened on the destination, only then I'm going to receive a SYN-ACK back. And if the TCP, if you see, that is host to host communication. But if there is a firewall or anything in the middle, if that blocks this port, or if the local firewall in the computer, if it blocks this particular port, your communication is not going to happen. So this is very important, you should understand. So example here, there is no firewall, it is just an end-to-end connection, and the port is open, and I receive a SYN-ACK back with the same 4 tuple parameters. I received that successfully, and I see I received the SYN-ACK back from the destination to my source. So I got my acknowledgement back. So for this acknowledgement, I'm going to, for this SYN-ACK, I'm going to an acknowledgement back again. And if you consider only this, your SYN and SYN-ACK, in the Wireshark with this, you can find your round trip time. So to understand the round trip time here, let me open up the Wireshark really quick. Okay, now I opened the Wireshark and there are a couple of captures running here. I see a SYN packet, it's a random packet. I'm just choosing the random packet here for a demonstration here. Let me follow the TCP conversation. I'm interested in the TCP conversation. If you see my filter here, this is my source IP. If I just do a TCP conversation, this is my source IP and this is my destination IP, and this is my source port and this is my destination port. Yeah, you can see the same thing here. So my computer, this is a conversation I filtered, and I can see the 4 tuple connection here. To filter any kind of conversation in TCP, you have to select this TCP conversation. And if you look at this, my computer here, my desktop, if you look at the IP details here, let me make it bigger. Okay. So here, I can see, let me change the color. So this is my source IP and this is my destination IP. And this is my source port, random port generated by the operating system. The destination port is a well-known port 443, HTTPS, TLS, right? So I got it here. So I got a SYN. I received a SYNAC. For the SYNAC, my computer is again sent a acknowledgement back. This is very, very important, the basics of TCP communication. So what else I can see? So let's go and drill down the TCP here. If I go to the TCP, let me lift this up. Okay, if you look at here, is my SYN. My SYN packet is marked, and you can see here my SYN, right? And coming back to the second packet here, my source port is changed. My destination now, the public IP address outside from the internet, 443 is responding to my same port. And what do I see inside the TCP flags? And I saw the acknowledgement back here, right? Both are marked SYN ACK from the destination. Then for this SYN ACK, I am sending an acknowledgement back again. You double click, open this, and if you look at this flags, I see the acknowledgement flag set. So why we are discussing this? That's important, yeah. So now, what I'm going to do now, let me fire up my Nmap tool to do a testing now. So how practically this works. For that, let me go back to my Nmap tool here. Okay, so here I'm going to do a port scan, a specific port. So this is my modem. Let me give a topology real quick. This is my modem sitting over there. And this is my PC. I got a wireless connection, my PC. It's talking to this modem. Yeah. Now why I'm running my Nmap tool here. And I'm doing a port scanning. And let me see what I can see in the Wireshark. So Nmap can be used for multiple purposes. So here we are going to look at the two key things here using Nmap. So the first thing is a port scan. And the second option is for host discovery. We are going to do both. So what I'm going to do for this modem, so for every device we know there is a management IP address for it. So for this modem, the IP address would be 198.168.0.1. And apparently that is my gateway, my local LAN, right? So here, my gateway would be 192.168.0.1. So from this Nmap, I'm going to do a port scan for the port 80. Let me check if my port 80 is opened and I'm trying to establish a connection there. And what happens and what I can see in the Wireshark. Okay, so to do that, this is a command. So nmap-p stands for the port 80 and for the destination 192.168.0.1. If I quickly do this, so my port 80 is opened, right? Port 80, yeah. Let me open the Wireshark. Let me start my Wireshark, quit this. Let me fire up Wireshark again. Go to my Wi-Fi adapter. It's dumping all my traffic here. So I'm going to give IP dot, this is a filter, right? So 192.168.0.1 and my TCP dot port equal to 80. So only I want to see the traffic for this. So far the packets are running here. You can see here my packets are running, it's dumping the traffic. Let me jump back to the Nmap tool, scans. Let me run the scan again. Let me go back to the Wireshark. Can I see the traffic here? Okay, so I have to give this command nmap -p port 80 nmap -p port 80 192.168.0.1. Okay, so let's see this. So what happened here? So since this is my local LAN, it took just 55 microseconds, right? This is one hop away. And if I open this, I can see the 4-tuple connection right away here. So here, this is my source IP address, and this is my destination IP address, and this is a source port. And I'm doing a port scan only for port 80 here. So what is the response here? So if I go to the Nmap, it says that the port 80 is opened, and I can see the MAC address of it. Yeah. The same value here. If I go back here, the MAC address is 9330, right? So from the modem, what is the response back I got? So from the modem, the port 80 is responding to 34489 because I tried with the port 34489. That's not, that's actually done by the operating system. It's a random port generated by the Windows for every communication. But the destination is a well-known port, and I can see the port 80 is responding back to this. But if I try to establish a connection, but because I didn't establish any connection right now, I'm just trying to scan. If you can just see, just by this scan, it initiated a TCP connection. And this particular, my computer is resetting this packet because apart from the scanning, I'm not doing anything. If I send any data over port 80, I should apparently see the application traffic coming down. So here, sometimes this happens, right? So let's jump back to the use case now. So let's take this topology. Example, if you have your a small topology, you have your switch and you got your server here. An example, your switch is connected to a firewall and you got a switch. This is a PC connected to this switch and this is a firewall. You got your upstream and downstream going to the firewall. Let me erase this. So your upstream is going back. Oh my God, again, it's wrong. 1 minute, let me erase this. So let me take this. Your downstream and your upstream. So example, this is your server is in your DMZ zone. And you have a DMZ subnet configured here. So that's something 192.168.0.1, and this server is 192.168.0.4. So you may try to establish a connection on port 80 to this server. And this computer, this is connected to a different network. Example, this is your inside zone. And it got an IP address 10.0.0.1. And both the DMZ and the inside subnet is configured here, and this firewall is just an L2, an example. So how your traffic would be, this 10 network is trying to reach, this 10 network is trying to reach this, and to open a connection over TCP on port 80, it should be open, right? So what if this, in this firewall, you have a rule to block port 80 for the destination 192.168.0.4. You have a rule from inside to DMZ, source any, and destination is 192. Sorry for that. Any, and the destination is this guy. Destination is this guy, destination. Any traffic going to this destination is blocked. Deny. You have a rule like this. And if you're trying to establish a connection, apparently you can see that here. But you know what happens there in the TCP three-way handshake that is not successful? Because I see a SYN, I see a SYNAC back, but for this, it's not sending any acknowledgement. And who is resetting the connection? That sometimes we struggle about, where it could be a source or destination. But if you use a TCP dump and if you do analysis the same like this, is it something because of this rule, it's denying this connection? Because this is coming from inside to DMZ and the traffic is any to this destination, the port is blocked. You can see this, who is blocking this traffic. And with the firewall rules, you can compare. You can change your rules based on that. So this how using the TCP, you can leverage your troubleshooting and you can understand better. This is one typical example. So let's jump back to the another use case. Example, let me try to do this. Let me go to the scans. Let me go to the subnet scanning. So looking at this scan, I can see all this active computers that are connected to this network, right? Just with one click here. But in the same way, if you do a traditional troubleshooting example, if there are users complaining that there are like this, the switches are daisy chained, right, to the core switch. And this is access switch. And this is your router. Yeah, you got all your VLANs here. So example, VLAN 10. It's 192.168.0.1. And you trunked and you tag VLAN 10. And here you see 192.168.0.168 is up and running. You can see in other switch, maybe 192.168.0.173. It's up. But for this, you have to open your CLI and you have to check your ARP, you have to check your MAC address table, and you have to track your ports one by one, and you have to check. Even the ARP you can check, but why it is failing. But this is a very quick way to find, right? I mean, okay, I can see only the 5 hosts are up and running. So is it my MAC address is flushed or the users are connected? A quick rundown, right? You can see that here. And if your routing exactly works, and what should I see here when I'm doing it? Yep. So for this port scan, so I have to use a command nmap -subnet -v that browse a detailed output 192.168.0.0/24. So let me open the Wireshark. Let me close this connection. Let me fire up Wireshark again. So I'm interested to check only this network, right? And ARP. Let me do scanning now. If you see, it's initiating an ARP ping scan. Let me change my filter. Let me stop this. Let me just type ARP. This is the output I am expected to see here. See, you can see there are a lot of ARP requests coming for all this destination because it is doing a port scan. You can see the protocol here. The very beginning, it is ARP scanning here, initiated a ARP scan. So let's jump back to the Wireshark and let me see. How do I troubleshoot this? Okay, so for this ARP request, did I receive a ARP response back? I can drill down, drill down. So you can see a lot of ARP replies, right? Just showing me the ARP reply backs. Okay, let's take this example. So it's telling that 192.168.0.197 is at this particular MAC address. I found this. So my routing works. I can see all my ARP requests. So I can see what are all the computers that's sending an ARP response back right away. So this host is up and running, right? And if you look at this 192.168.0.197, I got a reply back for this. This is an ARP reply. Yeah. You can see all the ARP requests and ARP reply back in one go. So using the Wireshark, this is how you can troubleshoot. Okay, I send an ARP request, but I didn't receive an ARP response back. Why? The destination is down or is the port is down. So that's giving you a complete insight of what exactly happening and how to troubleshoot, right? So you can see the same thing. What is the protocol used? And this, I can, match the same thing in the Wireshark and you can figure out. And you can see, only there are 6 to 7 computers that are up and running. I can see MAC address of it, and I can see the ARP response, but I don't see that in the Nmap. I cannot see the ARP request and ARP reply, but in the Wireshark, you can see the ARP request as well as the associated ARP reply back for the same. Yeah. See, this is, I'm doing an ARP request for the gateway, and it's telling this is the MAC address. So the whole objective of ARP is to find the destination, right? So we all know that. So I sent this particular Nmap is doing an ARP request, and this is a broadcast for 192.168.0.0/24. And from the Wireshark, I can see the ARP request and ARP response for the same, right? ARP request is a broadcast, ARP reply is a unicast. That's how we can use the Wireshark to figure out. And thank you for watching.